Hi, I'm Michelle. Welcome to Shared Threats, Web Application Vulnerabilities, and the ZOS environment. Today, we're going to explore the OWASP Top 10 vulnerability model for web apps and examine ways that this classification system can apply to the mainframe environment. What we'll cover are a few things. We're going to do an intro to what OWASP is, what the top 10 list is as well. We're going to look at some web app findings and techniques. We'll also explore some ZOS vulnerabilities and look at an attack demo. And finally, we'll wrap up with a few ways to secure the mainframe environment as it relates to web applications. So first up, who am I? Again, I'm Michelle Eggers. I'm a penetration tester with NetSPI. I've been there for a few years. I primarily work with Mainframe. I also test web applications, and I do a bit of network pen testing as well. Just this year, I've been a speaker at Cyberjutsu Day, DEF CON, B-Sides Las Vegas, B-Sides Saskatoon, and also Vanguard Security and Compliance. And now I get to do this great talk for Open Mainframe Project. So really happy to be here. Kicking off with web apps and OWASP. So first off, what is a web application? We all know we use them every day, mostly, but it's kind of nice to go back to the foundations and explore what they actually are so we're on the same page. So web application is really just software. It runs on a web server, it's accessed through a web browser, and it allows an end user to interact with the application over the internet. You don't have to install anything locally, right? It's a platform independent entity and it's available anywhere to internet access connections. Anywhere you have access, you can connect to a web application. And they're built with a combination of server-side and client-side technologies, HTML, JavaScript, backend frameworks like Python, Ruby, Java, anything like that. Common known things, they are all working together to make web applications what they are today. Now on a mainframe, we're going to go through a short list of the most common web applications that we find integrated with mainframes. So first of all, we see enterprise resource planning applications pretty frequently. These are business operation apps for finance, HR, procurement. Banking and financial systems, these are your core banking platforms, transaction processing systems, your online banking portals. We also have government services like tax processing, public services, Social Security, things like this. Insurance claims processing as well, customer data, policy management. You'll find airline reservation systems using Mainframe as well with their web applications for flight booking, schedule management, passenger information tracking. And we also see a lot of healthcare information systems with patient records, billing, and healthcare administration. This is not an exhaustive list, but these are some of the most common web applications that we do see integrated within the mainframe environment. Now we're going to talk a little bit more about OWASP. What even is it, right? So it's an organization. They create this list of top 10, right? These are the most critical security risks to web applications, and it's maintained by the Open Web Application Security Project, hence OWASP. It's a guideline for developers, security professionals, and organizations to address the most common vulnerabilities seen in the web apps, and it's updated pretty regularly to reflect what we are seeing occurring in the real world. It's not a static list. They're pretty consistent about updating. So we're going to do a little timeline here. We've got in 2001, it was founded by Mark Curphey as an open source project to help organizations improve their web app security. 2002, the first top 10 list was published. So that's 22 years ago, almost 23 years ago now. It's been around a while. It's pretty cool. 2003, 2004, it expanded to chapters around the world. They started hosting meetings and conferences locally to raise awareness. I've been to some of the OWASP meetups in Portland, Oregon, and they're pretty cool. Have some people from our organization who've spoken at them as well. It's just nice, sort of a grassroots setting where it's just practitioners and we're sharing information. Really cool setup. 2007, the second edition was released. Industry recognition was growing. 2010, it began to be widely accepted as a standard used by devs, security experts, and organizations. 2013, 2017, it continued to update the top 10 list, integrating new threats. 2019, there was more focus on software assurance models, secure code, became more of a focus, and other projects like the OWASP Application Security Verification Standard. There's some other ones that are coming out alongside the web app focused models. And then 20th anniversary was in 2021. That's when they released the most current version of the OWASP Top 10. And finally, present day, it's globally accepted, adopted tools, standards, educational resources. It's community focused. Like I mentioned, there are meetups all the time, conferences. It's a great organization. So, and the list is pretty comprehensive, I would say. It encompasses some of the most frequently seen things. Now, these are the top 10 as it currently stands. We've talked a lot about it. Here we are. We've got broken access control, cryptographic failures, injections, insecure design, security misconfigurations, vulnerable and outdated components. We've got identification authentication failures, software and data integrity failures, security logging and monitoring failures, and server-side request forgery. I don't have time to go through all of those today with examples, so the few that we're going to cover will be the following. We're going to look at broken access control, security misconfiguration, vulnerable and outdated components, and also identification and authentication failures. So to dig into those four with just a little more detail, number 7, AO7 2021, identification and authentication failures. This is when your authentication and session management functions are implemented incorrectly. So an example would be something like credential stuffing, session hijacking, or just simply using weak passwords, right? Number 6 on the list is the vulnerable and outdated components. This is when you're using components that have known vulnerabilities, which could be exploited. So using outdated libraries, right? Bootstrap, or frameworks or plugins with known security flaws. And then we've got number 5, which is security misconfiguration. This is when your security settings are improperly configured or left at insecure defaults, right? So if you're using default credentials or you're leaving ports open that are known to be insecure, it would fall into this category, right? So an example would be your database is left with a default admin password so that unauthorized users could access it. And then number 1 is broken access control, of course. This is when restrictions on what authenticated users are allowed to do are not properly enforced. So this is when, an attacker could potentially exploit the flaw and access unauthorized data or perform actions outside what their permissions have dictated they should be able to access. So you're bypassing these controls by modifying a URL, forced browsing, you're tampering with account numbers, or elevating privileges somehow. All these things would fall into broken access control. We're going to look now at some web application findings and techniques on how we found them. I'll walk through a few different real-world scenarios, actually, of findings that I uncovered during my testing. So before we get into that, we're going to look at a couple tools. Burp Suite is one, very, very commonly used. It is a web application security testing tool developed by Portswigger. It's used by pen testers, security researchers. We use it to identify vulnerabilities in web applications. I use it every time I do a web app test, every time. I don't get to use it as much with mainframe pen testing, but when they collide, when they interact, then I still get to use Burp Suite, which is nice. It's a great tool. Lots of good key features, but the top ones that will apply to the findings I show you today are going to be the proxy, which just means it intercepts and modifies your HTTP traffic as it goes from your browser to the target application, right? And then repeater, which allows you to manually modify and resend individual requests. It's really great. You can just grab out of proxy history and you can modify and resend, and it's really good for very granular manual testing. HTTP methods, this is important. You'll see why for a finding coming up. We're going to just do a quick refresher on it. They're used to define actions for web servers to perform on a resource within a client-server architecture within that relationship, right? The types, the most commonly ones are get, post, and put. I see these by far more than the other ones, but there are a few more that do exist. Head, patch, trace, options, and delete. All of these do exist. But again, the most commonly ones we will see are get, post, and put. All right. So this was an S3 bucket compromise onto the first finding of the day. This falls into the security misconfiguration category. To get ahead of something like this, you want to apply the principle of least privilege, right? So remove wildcard permissions as an example. Use pre-signed URLs to provide temporary or limited access to valid users for specific resources, as opposed to just assigning or just granting permission without any limitations. You can actually limit that a little more sufficiently. And then there's a cool tool called S3 check for my organization. Actually, you can check if unauthorized users have access to S3 buckets. So this is just kind of a little image. So you can see, here's your bucket, application server, and there's different ways you can connect into it. All right. So we're going to walk through it now. Here's the website. I've redacted the URL and different things here, but you access this non-production web application and you upload an image. That's the step one. Here's the image here. Business as usual so far. Nothing weird, very normal. And then what I did actually, I right-clicked the image to open it in a new tab. I just wanted to see what would happen. It's pen testing mindset. You just look for things, you try things, you check things that aren't necessarily part of the normal workflow. You just try it and see what happens. Well, in this instance, when I opened it in a new tab, the URL displayed the production S3 bucket location where the image was stored. So if you recall, I authenticated to a non-production environment. However, when I opened that image in a new tab, now I'm seeing their production location. Okay. So I went into my proxy history with Burp Suite, right, to grab that request. It's a GET request. That's why we talked about the HTTP methods, because I'm retrieving a resource. That was all I was doing. That was all that the website was doing when you open the image in a new tab. It was retrieving the resource. Something to note is that the response includes an e-tag header, right? The e-tag header will update when a file updates. This is important to remember for later. So it should remain the same if you're retrieving the same data every time. It shouldn't be updating. And then you can see down here just a bunch of characters to represent the data that's in the image. That's all that is there. Okay. So next we change this request method to put, which is used to deposit data. There's the inverse of get. And then I added some different data to the bottom of that request message. And I updated the content length as well so that it would be accepted by the server. And what I saw is that when I sent this modified request, I got a different e-tag header back in the response. Now, it wasn't a GET request, it was a put, so I didn't get anything back in the body of the response. So let's check and see if it actually was modified when I did that put request. So I replay the original unmodified GET request again to verify these changes, right? This is the response. Production data, or this is the original response, sorry, and then this was the new response. So the production data was overwritten, and you can see that by the change in the e-tag header. And you can also see that by the change in the message body and what comes back in the response. And this was all because of unauthorized access to that production S3 bucket. If you recall, I wasn't supposed to be in the production environment at all. So this falls into number 5, security misconfiguration. The S3 bucket data compromise was a security misconfiguration issue. It began with a leaked S3 bucket location for an image. It was just an image in a non-production site. Major culprit was improper segmentation of production versus non-production environments. The result was unauthorized overwriting of production files within the S3 bucket. The techniques used were simply modifying the HTTP request method from get to put, and then adding a bit of data to the body of the message and updating that content length header to make sure it would be accepted. So cloud services, APIs, or other things integrated with mainframes, it requires careful segmentation. Best practices will include thorough inspection of those configurations on a recurring basis. Next up, we've got an insecure direct object reference. This is a banking portal breach. This is the #1 broken access control. So to get ahead of something like this, you could implement UUIDs for your identifiers, for your account identifiers, restrict queries to resource owners, and you can provide perform authorization checks on the server side prior to giving access to resources. Client side, is typically not going to be enough. So I love this image. It just encapsulates the whole idea of what an IDOR even is. You go to a URL, you've got an identifier that is for, a specific account or resource. And then all you have to do is modify it a bit, and sometimes you can get things you shouldn't be able to get. So we'll see that coming up here. You authenticate to the main business banking site as a valid user, expected functionality, normal so far. You select an account to view more details, so far so good. Now, in proxy history, again, we can locate a post request that was sent to access that deposit account endpoint. When I clicked to open the account, this post request was sent out. Now, if we observe here, the request includes an account ID list parameter, and it has an associated value in the message body. The identifier is only 4 digits, as opposed to a GUID or some other longer or more complex identifier. So I wanted to look at that a little more once I noticed that. Simply by incrementing the ID in that original request to another value and resending that message, I was granted unauthorized access to other user accounts. So I modified it to 9443, and I was able to look at that account. And I could have just kept incrementing and looking at other accounts because of this specific vulnerability. Now, full access was granted. It wasn't just, oh, you can kind of see the page, but you don't really have permissions to do anything. Well, you could do this attack in the browser as well. All the transaction history could be downloaded from these accounts, and check images could be retrieved. I'm sure transfers could have been made as well, but this was a production environment. And so, even though I was told it was non-production, I had a feeling it was production, and it ended up being their live site. So I'm really glad I didn't actually do any test transfers, because it would have drained someone's real account. So we didn't do that. This was number 1, a broken access control on the OWASP top 10 is due to access control misconfigurations. Business banking accounts were assigned simplistic sequential identifiers that were much easier to enumerate than if it had been more complex. Account access authorization was not properly managed within the web application. And it would have been pretty easy for a user to steal data or funds from other users, or just tamper with their data. This was a pretty serious finding. This was a critical, in fact, and it had to do with the API that serviced the bank. So it affected multiple banks. It was pretty bad. So, it's important to secure access controls in your web applications, in your mainframes. And in a mainframe, if you're using ESM tools and proper LPAR segmentation, these are things that can help you make sure your access control is tight and the way it should be, clean and tidy. That's what we like to see. So now we're going to look at a ZOS vulnerability and attack demo. There's a few vulnerabilities, but there's only one attack demo. It's pretty great. Before we get into that, though, I want to show you a few things about how, just so we can get our head around how we would have a web application integrated with a mainframe. So you can containerize a virtualized Linux OS on a mainframe, right? To host for web server hosting using typical things like Apache or Nginx. You can use middleware to bridge the gap between your web technologies and your mainframe applications. So making sure that your JavaScript, HTML, your REST APIs can communicate with your COBOL programs or your CICS and IMS applications on the mainframe as well. A couple examples of that is ZOS Connect, IBM WebSphere. And you can utilize mainframes as a backend system. That's another way. You get a front-end web GUI on a separate server, maybe cloud, and then you're using APIs, right? SOAP web services to facilitate access to that mainframe data. And a few more ways are the IBM HTTP server that runs on the mainframe under ZOS. That's another way. It's more direct. It's right on the mainframe that way. You can use web enablement tools to sort of screen scrape, or otherwise it'll transform your legacy user interfaces like a 3270 terminal screen into a more web-friendly GUI. So if people aren't used to seeing the green typeface and these more, traditional terminals that you would find with mainframe, you can modify that so it's more approachable, I suppose, for people who are more accustomed to a web GUI look and feel. The Rocket Terminal emulator, and then the IBM HATS is another one. And then so in summary, mainframes very successfully merge with web applications. You can either have integration tools, middleware, or host it directly on the mainframe itself. These are all viable options and are used pretty regularly. Okay, so a little background, a couple things on the attack demo. So we're on the same page here. Apache Tomcat is installed on the mainframe's LPAR, and it's running on Unix system services. Okay, and then the front-end web app reads the Unix folder contents, and it removes the file type, and then adds these file names to a drop-down list. So the drop-down list is in the web GUI. You'll see it in the demo. And when you utilize the menu and you select, an option, Tomcat receives an HTTP post request when that file is selected, and it will retrieve the data from the mainframe and display it in the web GUI. Okay, so sufficient authorization controls are critically important for data protection. Again, use ESMs, RACF, top secret, whatever you need to do to protect this kind of communication, to protect your data. So you'll see me authenticate to the LPAR, assume that the endpoints have been previously enumerated, and access to sensitive resources is restricted for the low-level user. So the user that you'll see, it should not have admin or high access privileges. But the goal is to see if there's another way to access the data. All right, so here you see me on the NetSPI LPAR, entering my user ID. I'm authenticating here. I'm in ISPF. And now I'm going to open the command line utility within the mainframe, similar to if you're used to Linux, Unix, something like that, OMVS. So now I'm going to navigate to this previously enumerated endpoint. It says opt secrets location. I'm going to list out the file contents and see what's in there. I see there's a readme.txt and an SSH key. We're going to cat out the readme.txt. So this is the private key. You need to log on as an admin, do not share. Okay, well, let's look at the SSH key. I know I'm not an admin, but maybe I can, oh, permission denied, darn. Okay, well, game over, right? Wrong. No, I can go to the IP address that the LPAR is on, right? And I can go to the endpoint that I know connects to that Unix environment, that backend system, right? I'm going to go ahead and open the dev tools so I can look at the requests that are going in and out, and I can sort of modify things. You can do this here or in Burp. It was just a little easier to show it this way. So I send out that request. There's the post request at the top. I'll crack that open. I'm going to go ahead and look at it a little more depth, edit it, resend it. Here in the request, it shows the file name, right? That's in the request body. What if I modified that to the file I was previously denied from viewing? I wonder if I can get to it. Keep in mind, I'm just on the public-facing website. I'm not authenticated at all. Look at the request. Yep, that's in there. That's the endpoint. And what's in the response? I have retrieved the entire SSH private key. Now, this is a demo version, but it's based on a real world finding that we uncovered where it was very much possible to access secret data that was on the mainframe backend through the web application unauthentic. So a little bit scary. And it reminds us how important it is to follow up with our configurations, to inspect things thoroughly, to be diligent. This is broken access control yet again. Number one thing that we see on the OWASP top 10. It was an access issue via the integrated web application. Now the mainframe itself was properly configured. I couldn't access that file in the mainframe, but I could with the web app, right? The requests coming from the web app were not validated properly for access permissions. So the access control weakness made it possible to retrieve very sensitive data as a fully unauthenticated user. And this illustrates how important it is that we remain diligent about exploring the mainframes and all the things connected to them, because the smallest misstep could wreak mad havoc in an interconnected environment. And mainframes are very interconnected now. I mean, everything is interconnected. So we have to look at those connections. Now we've got a couple more mainframe security issues that I want to show you that I see very frequently in my testing that I do. One of them is unencrypted access over FTP or Telnet, right? So it just means that connections are permitted to LPARs or regions over port 21, port 23, similar. And this is number 6. This is a vulnerable and outdated components issue on the OWASP list. And it matters because your sensitive data is being transmitted unencrypted. Your usernames, your passwords, confidential files, anything that's being transmitted is going unencrypted from one point to another. There's no verification of file integrity, so if it was modified en route, the recipient wouldn't realize this. There's an overly simplistic password-based authentication for some of these protocols. And then in many regulated industries, using these protocols is non-compliant. So now you're out of compliance if you're allowing this as well. And sometimes people don't even realize that they're using them, which is why we test them and tell them. Another one is weak credentials being accepted. The problem here is that low complexity passwords and misconfigured authentication workflows can lead to pretty serious issues if we're looking at the potential for being brute force and getting, breached through that weak credential processing. So, and this is number 7. This is an identification authentication failure. With basic tools, a matter of seconds. With advanced tools, almost instantly, right? And this is referring to how long it would take to brute force the credentials if the passwords are not sufficiently complex. So those are the 2 things I see very, very commonly is weak credentials allowed or mixed case passwords allowed. They're not really enforcing that either. And then the unencrypted protocols. So a few ways to secure, so we're not leaving on such a scary note. For broken access control, you can configure RACF, TSS, or ACF2 appropriately. These are your ESMs, your security management tools. Use role-based access control, implement MFA always, and disallow authentication over insecure ports. And then we've got security misconfigurations. This is to use secure installation processes, remove unused features and frameworks. This can be a lift, I understand, especially if you've been using something for a long time, or you've gone through like 2 rounds of retirement with the person who was in charge, and now you've just inherited this beast and you've got to figure out what you even have in your stack. But it's really important to dig down all the way to the bottom, to the beginning, get into the foundations, get into the nooks and crannies, find the things that are not being used anymore and get rid of it. Get it out of there. And you can do automated configuration reviews. Number 6, vulnerable and outdated components. Regularly update your software, benchmark your baseline security configurations, audit often, and review your third-party integrations regularly. As we saw in that attack demo, third-party, well, that wasn't a third-party integration necessarily, but it was an integration, right? So even worse, if we take it back to the banking portal breach, that's a third-party integration because of the API in use. It was external from the bank. And so again, it affected multiple banks. You got to review these integrations constantly. And then identification authentication failures. This is specifically for mainframers. Implement passphrase on RACF in addition to password. It's just much more secure. It will increase the robustness 100-fold. Test your brute force resistance, right? Put it to the test. Don't be afraid. And enforce your password complexity, please. All right, so those are ways we know about how to secure, but there are new things coming up as well. AI use is underway on mainframes, currently expanding with the next-gen Telum 2 processor. That's going to provide some, potential improvements to security. Dynamic policy enforcement is another thing. Security policies can dynamically adjust based on the current state of the system. Real-time compliance monitoring. Mainframes they have this capability to continuously monitor compliance with industry standards like GDPR, HIPAA, PCI DSS, whatever it may be. Regulatory compliance is huge, and it's even getting more important lately. So blockchain for auditing is another thing. Blockchain tech is being explored to provide immutable records. Hybrid cloud security controls, so integrating cloud security features like IAM tools and compliance frameworks that work on premise and on your cloud systems. So it can keep an eye on that entire ecosystem for you. And that's it. These are all things that we use, right? If you're using a debit card, it's touching a mainframe. If you bank, it's gonna be connected to a mainframe at some point. You're using web applications daily. All of these things are important to keep an eye on as far as security and our general data safety as end users, as organizations. And it can seem daunting, it can seem overwhelming, especially when we locate these critical findings. That can be very scary, but as a team, if we keep our eye on the prize, if we remain focused and are brave enough to look into all of the corners and stick with it, it's going to work out. We're going to be safe. Thank you.